In this lesson, we are going to talk about similar figures. Similar figures are two figures that have the same shape but can be different sizes. So in this first problem, it says, tell whether each pair of polygons is similar, explain why or why not, and if they are similar, find the scale factor. So we're going to be doing multiple things in this problem, as you can see. So the first thing we have to do is figure out whether or not they're similar. So to do that, you're going to check the ratio of the sides. So I'm going to start with 8, which you can see right here. And 8 corresponds to side 4 in the second figure. So it's 8 over 4. And when I divide that out, 8 divided by 4, or if I simplify it down, is a ratio of 2 to 1. Okay, so now what I want to do is check the next pair of sides and see if that ratio is the same. So I'm going to write down 12 over 6. And when I simplify that, I can divide those both by 6, and I also get 2 over 1. So you can see that the ratio of the sides are the same. So what that means is the side lengths are, the scale factors are the same for the side lengths, so it means the side lengths are proportional. So the answer to this one is yes, the two figures are similar because the side lengths are proportional. We just showed that by showing that the ratios are the same, and the angles are the same. Okay, so by the angles, see how they all have 90-degree angles? So that means that the shapes are the same. Okay, so yes, these two figures are similar because they have proportional side lengths and the angles are the same. Okay, so letter C actually wanted us to find the scale factor. And the scale factor is this ratio right here, 2 to 1. So the scale factor you could say is 2. You could say it's 2 to 1. That's the scale factor. All right, so let's take a look at another example and try this again. So if we take a look at the next pair, again, we're going to determine whether or not they are similar. So what I'm going to do is take the pairs of sides. I'm going to actually do it at the top because I don't have much room here. I'm going to start with this side here. 3 over corresponds to this side here, which is 5. And that does not simplify. So then here I have 3 over 5, so that's certainly the same, so I'm not going to rewrite it. Here I have 3 over 5, so that's the same, I'm not going to rewrite it. And here I have 3 over 5, that's the same, I'm not going to rewrite it. But here I have 4 over 8. And 4 over 8 simplifies to 1 over 2. So one ratio is 3 to 5, and one ratio is 1 to 2. And since those ratios are not the same, that means that these two figures are not similar. So we're going to say, no, these figures are not similar because the side lengths are not proportional. Okay, and again, the reason we know they're not proportional is because when we found the ratio of the sides, they were not the same. So that's one type of question that you might be asked in regards to similar figures. Other problems. So in this problem, they're asking us to find the unknown length, and they tell us that these are similar polygons. Okay, so if you take a look at number 4, the unknown length is right here. It's letter N. So what we're going to do is write a ratio, or write a proportion. So N corresponds to 8.5. So it's N over 8.5 equals, and so now we're going to pick another pair of corresponding sides. So I'm going to do 4, and 4 corresponds to 12. So that's our proportion. So to solve for N, we're going to do the cross product. So we have 12 times N equals, and now we're going to do 4 times 8.5, and when you do that, you get 34. So then we're going to solve for n by dividing both sides by 12. So n equals 34 divided by 12 gives us 2.83 repeating. And there are no units on there, so I'm just going to write units. So we just figured out that this side right here would have to be 2.83 repeating if those two triangles were similar. All right, let's look at one more example like this. So again, we're finding the unknown side length, which is n. So I'm going to write n over, now n corresponds to 3 in the small triangle, equals, and now I need to pick another pair of corresponding sides. So I'm going to pick 21 over 7. And one thing I want to point out, see how n and 21 are both in the big triangle? So n and 21 have to be across from each other. 3 and 7 are both in the little triangle, so those have to be across from each other. All right, so now to solve this, we're going to do the cross products. So we have 7n equals 21 times 3, which gives us 63. And then we're going to solve by dividing both sides by 7. So n equals 9. And again, there are no units on there, so I'm just going to write units. So we just figured out that this right here would have to be 9 units if those two were similar figures. So those are some examples of how to find missing side lengths in similar figures.